Okay, so today we are solving exponentials using logs. We have solved logs, we've solved exponentials, getting common bases, we've solved logs using exponentials, so now we're going to solve exponentials using logs. Here's what this says. It says, if using a common base is not possible, then exponential equations can be solved using logarithms. So we would have to isolate the exponential expression, which, like on number 1, is already done. We're going to take the log of each side, because just like anything else you do algebraically, whatever you do to one side, you have to do to the other. Then they stay equivalent. Then we expand the logarithms if necessary using the power rule. And then solve and check for extraneous solutions. So we had to do that for logs, but do we have extraneous solutions for exponentials? Think about that. Your parent function for an exponential looks something like that, which means your domain is all real numbers. So if what I'm getting are values for the domain, are there any extraneous solutions? No. So that doesn't even make any sense. Okay, let's look at number 1. I have 3 to the x equals 80. And so there's no way I can take 80 and get a common base there. So I'm going to take the log of both sides. So I'm going to get the log of 3 to the x power equals the log of 80. Then I expand using the exponent, so x comes out in the front, so I get x times the log of 3 equals the log of 80. Then I am trying to get x by itself, so I'm going to divide both sides by the log of 3, so x equals log of 80 divided by the log of 3. Right? It's not the log of 80 divided by 3. It's the log of 80 divided by the log of 3. Okay? And even if I could reduce these numbers right here, I don't. Like, this is it. So now I'm just going to type it in the calculator. So you're going to go to the Desmos calculator that I had you go to today. And, hang on a second. All right. So, stuff's in my way. I'm going to go to function. Log is over here. Log. Got to go back to main of 80. Close my parentheses. Divided by function log main 3. And then you don't have to hit enter. Your answer is already right over here. But if you do hit enter, then it does give you a fresh, line for the next one. And unless we're told otherwise, how many decimal places do we round to? 2? 3. It's 3. The AP rule is 3. Okay. So unless you're told otherwise, 3 decimal places. So this is going to be 3.989. X equals 3.989. AP Calculus, your answer has to be correct to the nearest thousandth, unless you're told otherwise. If you're in AP Stats, it's actually the 10,000th. They use 4 decimal places. Why it's different, I don't know. I'm sure there's great reasons. All right, any questions on number 1? All righty, so let's look at number 2. We've got 5 to the x plus 1 power equals 18. So again, I can't get common bases here, but this time instead of using the common log, I'm going to use the natural log. So now the natural log of 5 to the x plus 1 power equals the natural log of 18. It does not matter if you use the common log or the natural log. If you use the natural log, it's less writing. Whatever. So now I'm going to take this x plus 1, bring it out to the front. That is 2 terms, so I'm going to put it in parentheses. So I get x plus 1 times the natural log of 5 equals the natural log of 18. Then, what do you think I should do next? I could distribute, but do I have to? I can go ahead and divide, so I think I'm going to go ahead and divide. So I will get x plus 1 equals the natural log of 18 divided by the natural log of 5. Then to get x by itself, I'm just going to subtract. So you get the natural log of 18 over the natural log of 5 minus 1. Notice no matter what you do, whether it's logs or square roots or whatever it is, your algebra steps are the same, right? So then we just got to get this typed into the calculator. So again, I'm going to go function. Here's my natural log of 18. Oh, I should have. Sorry, thank you. I didn't hit, yes, I should totally delete it. Actually, I'm not going to, I just didn't hit enter because I knew you couldn't see it. Like my screen isn't big enough, so maybe I should just do that. Sorry, I had it fixed, and then this thing down here won't go away. It's just been a mess today. But thank you before I went too much farther. All right, so let me do that again. Function, natural log of 18, close my parentheses, divided by natural log of 5. And then I want to subtract the 1 all in one step. So if you use these arrows, or you can use even the arrow on your keyboard that I don't have up here, and then minus 1. And then usually I hit enter when I'm done, even though I don't have to, so I don't have that issue. And now that I can do that because I can see it. And so that means my answer is 0.796. Any questions at all? All right. So let's look at number 3. So number 3, I don't get to just start by taking the log of both sides. I have to move this 25 first. So I'm going to subtract 25 from both sides. I'm going to get e to the 3x power equals what? You know, the easiest way to do that is to take 100 minus 25, that's 75, and add 8 back, and that's 83. All right, so now I'm going to take the natural log of both sides. I have the natural log of e to the 3x power equals the natural log of 83. Bring the 3x out to the front. 3x times the natural log of e equals the natural log of 83. Then I'm going to pause right here. What is the natural log of e? Okay, so I have the natural log of e. Let's say it equals y. Say I want to change that to an exponential. What's the base of this log? E, right? If it's a natural log, the base is e. So that would mean I would get the base, which is e, to the y power equals this, which is e, to the first power. So what is the natural log of e? 1. Because log base 3 of 3 is 1. Log base 5 of 5 is 1. Log base e of e is 1. Log base monkey of a monkey is 1. Like, it doesn't matter what it is, right? So anytime I have the natural log of e, this is just 1. So basically I have 3x times 1, which is just 3x. So now all I really have to do is divide by 3. So that's why if you have anything with the e's in it, using the natural log of both sides would be great. If you had an exponential with a base 10, use the common log. Otherwise it doesn't matter. It's not any easier. So x equals natural log of 83, just divided by 3. And I will let y'all type that in and tell me what you get. X equals what? 7, 3. Very good. All right. Any questions at all? We good? Awesome. All right, so then we're going to start this next one together. Then I'll let you finish it. What would be the first thing I need to do on number 4? Add the 1. Good. So I'm going to get 2/3 times 2 to the x minus 6 power equals 42. Can I multiply the 2/3 times the 2? Like, can I combine this here? No, I cannot make that 4/3 because I've got 2 to this power times the 2/3. So those aren't combinable. So I need to get rid of the 2/3. I do that by doing what? Multiply by the reciprocal. Good. So I'm going to multiply both sides by 3/2. So these cancel out. That's why I did it. So we get 2 to the x minus 6 power. And just FYI, on the right, let's work smarter, not harder. I don't have to multiply by 3 first. I can divide by 2 first. 42 divided by 2 is 21 times 3 is 63, and that makes that a whole lot easier. Okay. So now I have an exponential, can't get a common base, so I'm going to take the log of both sides. So the natural log of 2 to the x minus 6 power equals the natural log of 63. Oh, I told y'all I was going to let you finish. Okay, you finish this one up. Find x for me. So we get x equals 11 point what? 7. Yep, that's it. Any questions at all? Alrighty. Let's look at number 5. All right, so they're already isolated, not a common base, so I can't just set the little exponents equal to each other, so I'm going to take the log of both sides. So natural log of 8 to the 2x minus 1 power equals a natural log of 5 to the x plus 3 power. Oh, and I just realized those of you on Zoom, you may not even be able to read these little blobs. Sorry. You can probably figure it out after I do the next step. I didn't even think about that. All right, so I'm going to bring the exponents out front. So I get 2x minus 1 times the natural log of 8 equals x plus 3 times the natural log of 5. Okay, so this time I had more than one term on each side for the exponent, and I need to get all my x's on one side. So even if I divided both sides by the natural log of 8, I still got to figure out how to get this x over here, or vice versa. So although I didn't have to do this on the other ones, here I actually do need to distribute. So I'm going to distribute the logs to both of those. So this is going to give me 2x times the natural log of 8 minus the natural log of 8 equals x times the natural log of 5 plus 3 times the natural log of 5. Okay. So just like everything else you ever do when you are trying to solve an equation is you got to get all your variables on one side, right? So I'm going to move all my x's over to the left. So I get 2x times the natural log of 8 minus x times the natural log of 5. Then this natural log of 8 right here, since it doesn't have an x, I'm going to move it to the other side. So I'll have 3 times the natural log of 5 plus the natural log of 8. Okay. Everybody good with where everything came from? Okay, so now on the left, all my x's are on the left now. But I cannot combine these two terms because the logs are different. Like if this happened to be natural log of 8, then I could combine them, but we understand how like terms work and I can't combine those. But I have to get x by itself. Like that's my goal in solving. So what do you think I could do so I could get x all by itself? Factor out the x. Very good. So I have a GCF here. I'm going to factor it out. It's the only way I can get there. So just FYI, because that came very quick, which is amazing, and it should come quickly. But if it doesn't, last period it didn't. We had to talk through a lot. They were like, well, could we subtract? So what could we subtract? Like, because sometimes that's what goes through your mind when you're thinking through these things, right? Well, what if I divided by x? Okay, great. If I divide these by x, I have to divide this by x, then I'm just going in circles. So sometimes you have to think through the processes, but then you just ask yourself, it's just the same algebra you've been doing forever, so you factor out the GCF. Beautiful. So I get x times 2 times the natural log of 8 minus the natural log of 5 equals 3 times the natural log of 5 plus the natural log of 8. So as yucky as all this looks, look past all of that and just think algebraically, what do I do now to get x by itself? Divide, because it's being multiplied. So x equals 3 times the natural log of 5 plus the natural log of 8 over 2 times the natural log of 8 minus the natural log of 5. So then this time I actually did hit enter. So since I have more than one term in the numerator, I'm going to need to start with parentheses. Do 3 natural log of 5, close my parentheses, plus natural log of 8, close, close. So I can then do divided by, and since it actually makes it into a fraction, I don't have to put the denominator in parentheses because it's going to put it all down there anyway. So we get 2 natural log of 8 minus natural log of 5. Close my parentheses. Double check that I typed it in right. That's one nice thing about calculators, that you can actually see the stuff on. Boom, there's my answer. Okay. So I am supposed to round to 3 decimal places. When I round this, what's that going to make it look like? 710. 2.710. Yes, so x equals 2.710. Now, does 2.71 have the same value? Yes, but this tells me that I rounded it and there's other stuff out there. If you're supposed to round to the nearest thousandth, and let's say you get 2.75, and that's exactly what it says, 2.7, then your answer is 2.75. You don't add a 0, because adding the 0 says there's more stuff actually out there. Does that make sense to you? So there's my answer there. All right, any questions at all? All righty, last one. So I've got 2 bases that are different. So I'm going to take the natural log of both sides. Natural log of 9 to the negative 2x power equals the natural log of 2 to the 5x plus 4 power. Okay. Why don't you see if you can work through this one on your own? I'll give you a head start, and then I'll get it started. If you get stuck, ask me a question or look up here, but don't just copy mine down. Are you stuck? Sorry, I should be touching paper. Okay, well, how'd you get this over here? Right, but these are being multiplied. You have to distribute, just like we did up here. You have to distribute the logs. I like that you're using paper. Like I can come over here and actually see stuff. can see what you've been working on. It's great. You good so far? So distribute this will be 5 natural log of 2. I'm sorry, 5x natural log of 2 plus 4 natural log of 2. Yeah. Yeah, on the left-hand side, there's nothing to distribute. So, yeah. It just sticks together here. Say that again? I know. Well, and like I love when you're on paper and you're working on number 6, I can walk by and see what you did on 4 and 5, and that helps me see your work. So I can go, oh, look, make sure you do this or not that, and I don't know, whatever. I'm just over it. Okay. It should be fine. Yes, absolutely. If they're all flipped, then you're good, because what's going to happen is you're going to get a, yes. It's like if I multiplied through by a -1 now, that would change that positive and then negative, and it would be the same. So you just move stuff to the other side, right? Which is fine. It's absolutely fine. Okay. All right, so she had a very good question. Her question was, is it okay that my signs are all different than yours? So basically here, to keep it positive, which I do that a lot too, she added the 2x part over here and subtracted this over here. So in the end, her x is actually negative, positive, positive. But in the end, that's just like multiplying through by a -1. And as long as it all gets done, we should be good. And our x would be what? I don't think so. Yeah, -0.353. And I'll come figure out what went wrong over there. Oh, I forgot the negative. Okay. That happens, yes. All right, any questions at all? We all good? Okay, so whether Schoology is deciding to work or Google, whatever, I'm pretty sure Delta Math is working. Your assignment's in Delta Math, okay?